Hello everybody, welcome. Today's topic is zipping files in C#. We're going to see why we need zipping in applications. Later we'll see the type of library we use to zip files. And later we'll also see the restrictions we encounter while trying to zip files, especially the size and the naming conventions. And finally, we'll see the type of exceptions we can expect and how to clean up our services. We're going to zip a whole bunch of files. We'll later write a class to handle all our zipping needs. So stay tuned and watch till the end. So why do we need to zip files in our applications? The first one is when we're working with large file systems, sometimes we zip files to reduce their sizes so that we can archive them. Or in terms of web applications, example Google Drive, if you select multiple files and want to download them, Google Drive will automatically zip it for you so that it can be served in a single download rather than having multiple requests. And also, we reduce the overall size of our download when we zip. This, of course, comes with constraints, which we'll check later. So the library we're going to use today is system.io.compression. It's a library built into the .NET framework. There are several third-party libraries like .NET Zip, built by Ionic, WinZip, which offer Nuget packages you can download and zip files with, but these are third-party libraries. If there's a breaking change in the future, we'll have to incorporate that into our applications. But since we use system.io.compression, any future updates will be automatically included in the .NET framework, and we don't have to separately publish any changes. So we're going to go with this library. For this demo, I've built a simple console app in Visual Studio. I've already written a couple of methods that is going to help us zip files today. So let's see what they do. The first method is zip files. Let's open it. It has a variable that points to the f/zip/sounds directory. Let's quickly go to the directory. So this directory has a couple of MP3 files that we're going to zip in the sample. And after we declare this variable, we have a function called delete existing zip files. This method is just a utility method that I've temporarily built, which basically checks our zip directory and gets every zip files and deletes it so that we can easily just avoid duplicates in our project while we're testing. This is purely just for convenience for now, so let's not go into it. And finally, we have a function where we pass this list of directories called getFilePaths. Let's quickly go to that function and open it. So this function basically loops through all the directories we pass and then gets the files inside those directories and returns it as a list. Okay, so the first thing we got to do is let's go to our Nuget package manager and let's install the system.io.compression Nuget package. Let's install. Once we've installed it, let's come to our zip files function. Let's declare a using variable called zip is equal to zip file dot, and we have a couple of options, and we're gonna use the open method. We gotta pass an archive file name. So let's declare a file name, zip file name. We're gonna put it in our f/zip and call it my zip file.zip, and let's pass the zip file name and zip archive mode. We have a couple of modes here. We can either create, read, or update. Since we are creating it from scratch, let's use the create. Once we've declared the zip variable, we can loop through all the file path, and we can add this using the create entry from file. So we have two parameters. The first one is the source file name, which is the file path, and the second one is the entry name, which is the file name. Here we have the whole file path, so we'll have to get the file name. So let's declare a variable path.getFileName. So path.getFileName is an inbuilt method which takes a path and gives you the file name only. So let's get the file path. Once we get that, let's enter the file name here. And once we have it, it should be good to go. So everything looks good. So let's run the program. Control F5. Everything looks good. Now let's go to our f/zip folder, just right here. And we have our zip file here. Let's open it. And there we have it. We have the 3 files zipped into our folder. That is great. So here we have a simple program that takes a list of file paths and generates a zip file for us. It's very simple, right? Well, not exactly. When it comes to creating zip files in Windows, we have a couple of restrictions. The first is not exactly a restriction, but a feature. In zip files, you can have duplicate file names. So 2 file names can be the exact same and we can still zip it. But the issue arises when the end user tries to extract it. There, they'll have a couple issues where they'll have to either replace the files, or they have to skip the files, or they have to individually extract it, which in my opinion is not great user experience. And the second restriction is the file size. Zip files cannot be more than 4 gigabytes in the Windows file system. If you try to create an archive greater than 4 gigabytes, your process will fail. So let's see first how to avoid duplication of file names, and later we'll see how to create multiple files so that our archives don't get bigger than 4 gigabytes. So for this, we're going to be using a specific algorithm, and here it is. So let's take a quick look. So we start with our process, and then we check if our queue is empty. If it's empty, then we stop. Oh, let's go back. If it's not empty, then we check if the archive is greater than 4 gigabytes. If it's not greater than 4 gigabytes, then we check if the name exists in our current archive. If it exists in our archive, we pass our file name to our renaming algorithm, and then the renaming algorithm comes back and checks in the same archive. And if it still exists, we repeat the process until the file name is unique. And then once we have a unique name, we add our file to our archive. And then we go back to our queue and we check if our queue is empty. And say, for example, if our archive at this point is greater than 4 gigabytes, then we'll have to flush out our current zip file and then create a brand new archive and continue the whole process until our queue is empty. So let's go to our program and see how to create this. Okay, so for this example, I've declared 2 directories, one sounds and the second one is sounds1. Let's open them. Let's come to our zip folder. So sounds has 3 files, so and so, and sounds1 has the exact 3 files. So when we pass these directories to our file paths, we'll have 6 files with 3 repetitions. So let's see what happens when we run the program. So Control F5, the program is done. Let's go into our zip folder, my zip file. So there we see it. We have each file has a repeated because it's getting from 2 folders and the zipping system allows it. So you can ask me, what's the issue here? We'll see the issue. So let's go back and try to extract it. Extract all. Let's extract it to our folder here. And while we extract it, we get a notification asking us to if we want to replace the files or if we want to skip the files. This is an issue. Imagine if Google Drive gives you a zip file and you run into this problem. Though it's acceptable, it's not good user practice. So let's see how we can rename the files before we can zip them. So before we continue, I've went ahead and extracted our functionality into a separate class called zip file service. And this service has a method which compresses files, and it takes a parameter called file paths. And we basically declare a file for our target zip file, and we basically do the same archiving process as we saw before. And then finally, once we're done archiving, we just return the zip file name back to our program.cs. Let's quickly go back. And here we just initialize a zip file service, and we call the compress files when we pass the file paths. And once complete, we get the zip file back, and we just print it out right here. Okay, now let's see how to rename files before we can zip it. Okay, so let's see how we can generate unique file names in our zip. So if we come to our service, so this is where we get the file name. So here, instead of directly getting the file name, let's write a function called get unique file name, and we're going to pass the file path. Let's generate this method. Okay, and here we are going to write a couple of variables. The first one is file name without extension. We're going to get it from get path.get file name without extension and get the file path. Later we'll get the file name. Actually no, let's get the extension. Let's get path.get extension file path, and then we'll get the new file name. This is going to be an arbitrary name just from the file name. Get file name, and let's path the path. Okay, and then here we'll have to check if the current archive has the new file name. So this is where we actually have to maintain a state variable in the whole class where we can check if our archive has this current file name. So for that, let's create a private list. Let's call it files in current archive is equal to new list. And let's come here and let's check. We're going to check if the file name is equal to new file name. If it exists, then let's declare a count variable right here. We're going to increment it. And finally, we're going to set the new file name to this format. First, we're going to get the file name with that extension, and then followed by, we're going to put the number in the brackets. Then finally, we're going to put the extension. And then this will loop until we have a unique file name. And then finally, we'll return the new file name. That is great. So here, so every time we create an entry into our zip, we will have to add the file name into our archive. So let's add the file name right here so that the state is maintained. And that is great. So now let's run the program and see if this works. Control F5. Okay, our file is complete. Let's go inside. Zip file.zip. And there we have it. So every repeating file has the count inside brackets, one after another. That is great. Okay, now we solved the problem of having duplicate names in our zip archive. Now we're going to look at the second restriction, which is 4 gigabytes. So right now in our folder, we have only about 2.5 megabytes of items. So we literally don't have any issues, but if it's more than 4 gigabytes, we will have to create multiple archives. So let's see how to do that. Okay, so we are back in our zip file service, and in our compress files, at the moment, we assume that there's going to be always only one zip file returned. So we'll have to change this to return multiple zip files. For that, let's change this into an enumerable of string. And this is going to be a list of zip files. So for that, I am going to declare a new list of string called archives. This will be a global variable which maintains the list of archives that are created. And then finally, once we're done compressing, we're going to return it here. And here in our for each loop, I am going to extract adding the zip archive into an external method. So let's declare a new method called private void add to archive. It takes two variables. One is a zip, and the second one is a string of file path. Okay, and then we can actually extract the entire thing into here, and then we can call add to archive zip and file path. Actually, we'll have to check if this file exists. So in that case, let's declare a file info is equal to new file info of file path, and we're going to check if file info.exists. If it doesn't exist, then we basically loop. Then finally, we pass the file info right here, and this has to be changed to a file info. And here we'll pass the file name, and we will pass the full name. This will get the file name, and this will get the full path, and we'll have to rename this into file info. Okay, that looks good. So the next step is to go to our add to archive method, and here, just before we add a file to our archive, we have to check if the size of the archive is going to be less than or equal to 4 gigabytes. So before we do that, I'm going to create two variables. The first one is a private double. This is going to be current archive size initialized to 0, and private double max archive size, and this is going to be 4 gigabytes, which I've copied here. This is approximately 4 gigabytes. Okay, so this variable is going to track this current file size of our archive, and this represents the maximum archive size. So let's go back to our add to archive method right here, and we're going to write a check if current archive size is greater than or equal to max archive size, or if current archive size plus file info dot length is greater than or equal to max archive size, then we create a new zip archive. So what's happening here? So first, before we add any entry into our zip file, we check if the current archive size is greater, or if the current archive size plus what we're going to add to our archive, if it's greater, then we create a brand new zip archive. So let's see how to do that. So in order to make this work, you'll have to do two things. First, we'll have to track our archive size right here, and we're gonna plus file info dot length. So this way, every time we add a file to our archive, we sum the current byte size into our current archive size. And the next thing, we're going to write a method right here called create zip archive. Let's write it right here. Private void create zip archive. So what this method is going to do is create a zip archive every time we call it. So I'm thinking maybe we should extract this zip into a global variable. So let's do that actually. So I'm going to delete the zip from here and delete the zip from here. And let's come to our global and private zip archive zip. Okay, and this is going to be null by default. And since it's a global variable, we're going to rename this to zip. Then let's come back. So right here, we're going to first dispose it. So what does this mean? So this is basically, so the way the zip file system works in the system.io compression is, it's a stream. So the moment you, let's go back to our create archive method. Okay, right here. So the moment we open this right here, we start a stream. So this stream will basically have it open, and until we dispose it, it will be open. So here, before we create an archive, we basically say, let's dispose it if it exists. And then we will say zip, and we'll have to actually extract this here too. Let's cut it and paste it here. Okay. So instead of zip here, this is going to be a global zip. And then finally, after we initialize it here, we'll have to reset the current archive size to 0 so that we tell our counter that it's a brand new archive. And also the files in current archive should be initialized to new because it's a brand new archive. And everything else looks good. And also, final step, because this is a brand new archive, we'll have to add it to our archive right here. Let's add it, call it zip file name. Okay. So we have a small issue. Our zip file is hard-coded right here. So let's write a method called get zip file path. So this returns F. Let's put an @ symbol so that we can write backslash. It takes a zip slash, and instead of hard coding it like this, we are going to use a GUID dot Nuget and dot zip. Okay, and then instead of this, we're just going to call it right here. Okay, so this creates zip archive, disposes it if we currently have a zip archive, and then gets a zip file path, initializes it, resets the counters, adds it to our archive, and its job is done. And let's come back right here. So also we need to add one more check here. So let's assume that our program runs for the first time ever. In compress files, it comes here, and once we pass here, we call our add to archive method. Here we haven't initialized the zip variable. So if zip equals null, then also we'll have to create a zip archive. Okay, that looks good. Let's go back to our compress files method. So here I am gonna wrap the whole thing in a try catch block. Let's move this inside here just in case, and then we'll have to add a finally block here. Once this is complete, I am gonna write zip.dispose. Why do I do this? Okay, so we have our for each loop running, which creates an archive. And say, for example, we have an archive that's created, used, and finally, if we don't dispose it here, it will not be valid and it'll cause problems. So we're going to add it right here. And the next step is to actually check. So right now I have a max archive size of 4 GB. So it is not going to cause any multiple files to be generated. It'll be a single file, but still we're going to check it. But before that, let's update this right here, string dot join. I'm just gonna put environment dot new line and this. Okay, now let's go back and control F5. Okay, we have one file here. Okay, it's a GUID, and we have our 6 files. Now let's see if we can generate 2 files. For that, I'm going to go back to the zip file service. So instead of having a max archive size of say 4 gigabytes, I'm going to change it to about 2 megabytes. Let me copy the size from here. So this is 2 megabytes. We're just going to use this for testing purposes so that we can see if the splitting is going to work. So let's run our program, Control F5. Okay, this time we have zipping complete and we have 2 files, 1 and 2. Let's go to our folder, and here we have it. We have 2 folders. Let's check the first one. We have 4 files totaling almost 2 megabytes, and the next one is less than a megabyte. Okay, that looks great. So the next thing, let's go back to our zip file path. Here we have hard-coded the base path, which is f/zip. It's okay, but if you want this class to be truly a service, it has to be flexible enough to change the path. So for that, we are going to introduce our in our constructor a variable called base path, and we're going to introduce a read-only field called base path. This is going to be a folder. So we're going to check if directory.exists base path. If it does not exist, we are going to create this directory.create directory base path, just to make sure. And then finally, when we get our zip file path, instead of hard coding it here, we're going to delete this and we're just going to pass base path. And since we passed this here, let's go back to our program.cs and let's declare a variable called base path is going to be zip, and then let's pass this base path to right here, and let's control F5, and we have 2 files generated. Awesome. Now we have a fully functional zip file service which generates zip files for us with all the conditions that we expect. But let's quickly go back to our compress files method. So let's assume that during our for each loop, say out of a total of 8 files, during the 4th file, there's an exception and our whole process fails. So what do we do that time? So let's assume that we already generated, say, 2 zip files for this process. And since the whole process fails, we will have to clean it up. We'll have to delete those generated zip files, or else our system will just keep on adding more and more zip files and we'll run out of space. So let's say if we run into an exception, we will have to somehow delete all the existing archives that we created in this specific process. So for that, I am going to declare a variable called isError set to false. Let's just rename it properly. And then when we have an exception, I'm going to set it to isError to true. And then finally, when we come here, we check if isError. Let's give the right name, and then we delete existing archives. Okay, and then let's generate this method. So what's happening here? So the way try catch and finally works is after the catch is executed, if there's an exception that's caught, the control will automatically fall to finally. Here, since if we have a current archive, we basically delete it, and then if there's an error, we call the delete existing archives. So here we just have to loop through all the existing archives and delete it. For that, let's write a for each loop, and we track all the archives in our archives method. So let's call it archive, and we check if file.exists archive, file.delete archive, and that's it. So now if ever there's an exception or there's a failure in the process, we can be assured that our system will not generate junk files and not eat all the disk space we have in our servers. Thank you so much for watching. If you have any questions, please leave it in the comments section. I'll get back to you as soon as possible. And please subscribe to the channel if you can. Thank you so much.